Welcome to the Resource Allocation Decision Tool, Help Video 4.2. My name is Terry Haines. This video focuses on the different types of economic evaluation that you might encounter in the health literature. There are four broad types of economic evaluation you are likely to encounter: cost minimization, cost effectiveness, cost utility, and cost benefit analyses. All measure costs the same way. However, they differ specifically in how they treat the consequences. In a cost minimization analysis, the benefits or the consequences of the options being compared are assumed to be equivalent. The analysis outcome is expressed as a difference or ratio in the cost. The second form of economic evaluation is the cost effectiveness analysis. Benefits are measured in natural units. Effects are usually expressed as a health outcome, for example, the number of falls prevented or number of patients without pain. However, other effect measures do exist in the literature. You might encounter process measures such as the number of surgeries performed or the number of students educated. The analysis outcome is expressed as an incremental cost per additional outcome unit. For example, the incremental cost per additional fall prevented. A cost effectiveness analysis outcome may sometimes be represented graphically on a cost effectiveness plane. Here, the y-axis, the vertical axis, represents the cost of the interventions being compared and whether it favours the control condition or the intervention. The x or horizontal axis represents the clinical effect on the health outcome. Here, to the west side, it favours the control, and to the east favours the intervention. This red dot here indicates what the incremental cost effectiveness of a particular intervention might hypothetically be. When trying to understand the effectiveness of interventions, we often talk about confidence intervals, 95% confidence intervals usually. However, when we talk about a cost effectiveness estimate, we talk and demonstrate uncertainty by using a cost effectiveness ellipse. This is necessary because a cost effectiveness ratio has two dimensions, not one. The circle or ellipse demonstrated in this particular cost effectiveness graph demonstrates the area in which we are 95% confident that the true cost effectiveness estimate of an intervention lies when that intervention may be applied more broadly. I urge you to be careful when considering the cost effectiveness ratios of interventions that you may see written up in the research literature. Always consider the range of costs that have been considered. For example, consider option A, where a study reported that it cost $50 per fall prevented, but did not consider the future cost savings from each fall prevented. Also, option B, where a study reported that it cost $50 per fall prevented, but already had considered the cost saving from each fall prevented. A superficial contrast of option A and option B might lead you to think they're equivalent. Both cost $50 per fall prevented. However, if I were to tell you that each fall costs $1,000, I want you to consider how this changes your interpretation of these cost effectiveness ratios. For me, this makes option A appear much more attractive because that $1,000 saving per fall prevented had not already been considered in that $50 per fall prevented estimate. The third type of economic evaluation is a cost utility analysis. This is a type of cost effectiveness analysis where benefits are expressed in terms of quality adjusted life years gained. This is a measure of health-related quality of life, which is often measured on a scale between 0 and 1. Negative values are also permissible on some scales to represent health states that the community believes are worse than death. To calculate quality adjusted life years, you multiply health-related quality of life by the amount of time in which that health state was lived. So, for example, living 1 year at a health-related quality of 1 equals 1 quality adjusted life year. Living 2 years at a health-related quality of life of 0.5 also equals 1 quality adjusted life year. The analysis outcome of a cost-utility analysis is often presented as an incremental cost per additional quality adjusted life year gained. The final economic evaluation approach that you may encounter is a cost-benefit analysis. Here, the benefits are expressed in monetary terms. The contingent valuation method can be used to do this. The analysis is commonly presented as a net benefit, such as a difference between the costs and benefits of the options being compared, or as a benefit to cost ratio, which is simply a ratio of benefits to costs. In the resource allocation decision tool, you might now consider the language that we have used in this question. Here we've talked about the cost effectiveness of an option in addressing a particular problem, and then talked about being highly cost effective in terms of the benefits being much greater than the costs. This language is not entirely consistent with the 4 different types of economic evaluation that you will encounter in the health literature. However, we have used this language because we feel this is going to more commonly reflect the use of these terms by people who use the ReAD-iT tool.